Sometimes the universe presents us with puzzles that demand our attention in ways we never anticipated. I often find myself staring at the night sky from my backyard in Massachusetts, wondering about the messages encoded in the ancient light reaching us from across the cosmos. But occasionally, those messages arrive much closer to home. On July 1st, 2025, the Atlas survey in Chile captured something extraordinary, a faint speck of light moving against the backdrop of fixed stars. Within days, we confirmed what made this discovery significant. Its hyperbolic trajectory revealed it wasn't from our neighborhood. This was the third interstellar object we've ever detected, following Oumuamua in 2017 and Borisov in 2019. We designated it 3I/Atlas. What makes this visitor so compelling isn't just its origin beyond our solar system, it's what we've learned as it journeys toward our sun. The James Webb Space Telescope directed its sensitive instruments toward Atlas and revealed something unprecedented, a coma dominated by carbon dioxide with minimal water vapor, unlike any comet we've previously cataloged. The spectrographic analysis published in the recent AirExiv preprint 2050-8.18209 shows chemical ratios that simply don't align with our established models of cometary composition. Swift's ultraviolet optical telescope detected hydroxyl emission at 3.5 astronomical units from the sun, suggesting water loss of approximately 40 kilograms per second. This finding, detailed in RxIve 2508.04675, would normally suggest a fairly typical cometary body. But here's where conventional understanding begins to falter. The ratio is wrong. Everything we know about cometary composition suggests this object shouldn't exist, at least not in the form we are observing. Ground-based observatories in Spain and Japan measured something even more puzzling, extreme negative polarization in the light reflected from this object. In my 30 years studying astronomy, I've never encountered a comet displaying this optical signature. According to the findings published in RSIV 2509.05181, the polarization values exceed anything in our historical records. It's as if the microscopic particles surrounding the nucleus are arranged in geometries fundamentally different from anything in our solar system. As Atlas approaches perihelion, its closest passage to our sun, its growing tail should be providing answers. Instead, it's generating more questions. The tail has expanded dramatically in recent weeks, which we would expect, but its morphology defies prediction models. There are structures within the tail that appear to maintain coherence despite solar wind buffeting that should disrupt them. The Associated Press published images just last week showing this remarkable growth, but what the casual observer might not notice are the subtle structural anomalies that have my colleagues exchanging concerned emails at midnight. What truly captured my attention was a curious incident last week. During a critical observation window, NASA's primary data feed went offline for approximately 16 hours.
When it returned, the explanation offered was routine maintenance, yet the timing seems remarkably unfortunate. The European Space Agency experienced similar technical difficulties during this same period.
Coincidence is always possible, but in science, when multiple independent systems exhibit synchronized behavior, we begin to look for connecting mechanisms. More intriguing still are the faint radio emissions detected by the Green Bank telescope. These signals appeared only during the brief moments when the telescope was repositioning between observation sequences, as if something was only transmitting when it knew our instruments weren't directly focused on it. The signals didn't repeat during dedicated follow-up observations, which would typically lead us to dismiss them as interference or instrument artifacts, but their specific frequency distribution showed patterns that some of my colleagues find difficult to attribute to random noise. The radio signatures displayed a narrow band concentration around 1.4 gigahertz with precisely spaced harmonic components, the kind of mathematical regularity that rarely emerges from natural processes. When I first reviewed this data, I was reminded of the famous WOW signal detected by Ohio State University in 1977. Both share that distinctive characteristic of appearing mathematically significant yet frustratingly non-repeating. Perhaps most peculiar is the behavior of the tail itself. On 3 separate occasions, the tail orientation shifted in ways that appear to bend toward the sun rather than away from it, the opposite of what solar radiation pressure should produce. It's almost as if the object were making course corrections, though natural explanations involving uneven outgassing or rotational dynamics could potentially account for this behavior. What makes these shifts particularly noteworthy is their timing. Each occurred immediately after the object passed through regions of increased solar wind activity, almost as if responding to environmental changes. I've heard from colleagues that senior researchers from several space agencies have been meeting behind closed doors to reevaluate the preliminary findings. This isn't necessarily unusual. Scientific consensus requires robust discussion, but without corresponding iron, a metallurgical fingerprint that challenges our understanding of stellar nucleosynthesis. These elements typically form together in supernovae, remaining coupled through planetary formation processes. Their separation suggests either unknown chemical processes or potentially, though I hesitate to speculate too broadly, intentional refinement. Another aspect that deserves closer examination is the object's mass. Based on its observed luminosity and estimated size, 3I Atlas appears to possess a density significantly higher than typical cometary bodies. If these calculations prove accurate, we're looking at something potentially composed of materials more similar to planetary cores than cometary ice. This anomaly alone wouldn't justify extraordinary hypotheses, but when combined with the other observations, it creates a pattern that grows increasingly difficult to explain through conventional frameworks. The implications extend beyond merely cataloging another interstellar vagabond. When I look at the confluence of anomalies surrounding Atlas, I'm reminded of Arthur C. Clarke's famous observation that any sufficiently advanced technology would be indistinguishable from magic. I'm not suggesting this object is artificial. Extraordinary claims require extraordinary evidence, and we have not crossed that threshold. But I am suggesting that our scientific framework should remain flexible enough to consider all possibilities that fit the data. Think about our own civilization's trajectory. We've only been technologically capable for a brief cosmic moment, yet we've already sent Voyager, New Horizons, and other probes into interstellar space. If our civilization continues advancing for even a few thousand more years, a blink in cosmic time, we might send sophisticated probes to hundreds or thousands of nearby star systems. Is it so implausible that other civilizations, potentially millions or billions of years more advanced than ours, might have done the same? The question isn't whether intelligent life exists elsewhere in our galaxy. Statistically speaking, it almost certainly does. The question is whether we are prepared to recognize its artifacts if they pass through our cosmic neighborhood. Our scientific instruments are designed to measure natural phenomena. Our analytical models presuppose natural origins. Even our language constrains how we think about objects like 3I Atlas. We call it a comet because that's our closest conceptual category. But what if that categorization itself blinds us to its true nature? I faced criticism throughout my career for entertaining these possibilities. Some colleagues consider such speculation harmful to scientific discourse, but I would argue the opposite. The most harmful approach to science is dogmatism that refuses to follow evidence where it leads. The history of science is filled with moments where anomalies that didn't fit existing paradigms were initially dismissed, only to later become the foundation of revolutionary new understanding. Another notable feature of 3I Atlas is its trajectory. The object's path through our solar system lies within just 5 degrees of the ecliptic plane, the flat disk where our planets orbit. This alignment is surprising for an object of interstellar origin, which should approach from random directions. The statistical probability of such close alignment happening by chance is less than 1%.
Add to this the object's remarkably close approaches to Mars and later Jupiter, and the combined probability becomes vanishingly small, less than 1 in a million.
Probability alone doesn't prove intent, of course. Unlikely events happen all the time in a universe as vast as ours, but science progresses by recognizing patterns that deviate from random chance. If I flip a coin and get heads 10 times in a row, I'm justified in examining the coin more carefully. 3I Atlas represents that kind of statistical anomaly, not proof of anything extraordinary, but certainly justification for extraordinary scrutiny. When I gaze at the spectroscopic data from Atlas, I'm looking at chemical signatures from another star system. When I analyze its trajectory, I'm tracing a path that spans interstellar distances. When I consider its composition, I'm touching materials that formed under conditions we can barely imagine. These facts alone are wondrous enough without requiring any exotic explanation. But science progresses by questioning, not by assuming we already have all the answers.
As we continue tracking Atlas through its journey around our sun, I'm struck by how this small visitor has generated such enormous questions. Its perihelion passage in late October will provide our clearest view yet.
If the anomalous patterns continue or new ones emerge, we may need to seriously consider explanations beyond our conventional frameworks. I am particularly interested in how the object will respond to the intense radiation and gravitational forces at closest approach. Natural materials should exhibit predictable behaviors under these conditions. Any deviation would be informative, regardless of the explanation. The implications of such a paradigm shift would be profound. We've spent centuries assuming we're alone in the cosmic darkness, or at least alone in our corner of the galaxy. What if we've been wrong? What if evidence has been passing through our solar system and we've been too constrained by our assumptions to recognize it? The psychological and philosophical impact would rival the Copernican revolution that displaced Earth from the center of the universe. Let me be clear about something important. Uncertainty is not weakness in science. It is honesty. When I discuss these possibilities, I'm not claiming to have definitive answers. I'm advocating for open-minded investigation. The preliminary data on 3I Atlas contains genuine anomalies that warrant serious scientific attention. Whether those anomalies ultimately resolve into conventional explanations or lead us toward the new horizons of understanding remains to be seen. Consider this thought experiment. If an advanced civilization wanted to study emerging technological species across the galaxy, what method would be most efficient? Perhaps not direct contact, which could be disruptive or dangerous. Perhaps not massive spacecraft, which would require enormous energy expenditure. Perhaps the most logical approach would be small automated probes, cosmic anthropologists, quietly observing from a distance. If such probes existed, they might intentionally appear similar to natural objects to avoid immediate detection, revealing their true nature only to species sophisticated enough to notice subtle inconsistencies. This concept of a Trojan horse strategy isn't just science fiction. It represents a logical approach to galactic exploration that minimizes energy expenditure while maximizing information gathering. A civilization capable of interstellar travel would likely prioritize efficiency and stealth, especially when studying potentially unpredictable emerging technological species like ourselves. If I were designing such a program, I would create probes that blend seamlessly with the natural celestial environment, only revealing their true nature through subtle anomalies that would be apparent only to societies advanced enough to detect them. Again, I'm not claiming this is what 3I Atlas represents. I'm suggesting that as we analyze this interstellar visitor, we should remain cognizant of our own observational biases and limitations. The most significant discoveries often hide at the periphery of what our instruments and minds are designed to detect. What strikes me as particularly noteworthy is the timing of these interstellar visitors. After billions of years during which we noticed none, we've now detected 3 in less than a decade. This could simply reflect our improved observational capabilities. We couldn't see them before, but they were always passing through. Or it could suggest something more directed, a sequence of objects following similar trajectories with purpose rather than chance. The statistical improbability becomes even more striking when we consider the specific timing relative to our technological development. Humanity became capable of detecting interstellar objects only recently with the deployment of advanced survey telescopes. The fact that we've observed 3 such objects precisely during this narrow window of technological readiness could be coincidence, but it could also suggest objects that deliberately timed their arrivals to coincide with our ability to detect them. I realize this sounds speculative, but pattern recognition is a fundamental aspect of scientific investigation. The silence from certain institutional channels regarding Atlas's more unusual characteristics reminds me of cultural patterns I've observed throughout my career in academia. There's often a reluctance to engage publicly with anomalous data until conventional explanations have been thoroughly exhausted. This caution serves science well in many contexts, preventing premature sensationalism, but it can also create blind spots where significant patterns go unrecognized simply because they don't fit neatly into existing categories. During a recent conference call with colleagues from several major observatories, I noticed an unusual hesitancy to discuss certain aspects of the data. Topics that would normally generate enthusiastic debate were instead met with awkward pauses and changes of subject. This behavior itself represents a kind of data, not about 3 Atlas directly, but about how the scientific community is processing information that challenges established paradigms. As Atlas continues its journey, it will pass 167 million miles from Earth in mid-December. This will be our final opportunity for detailed observation before it returns to the interstellar void, carrying with it whatever secrets it holds. The window for discovery is narrow, and I worry that institutional inertia might prevent us from asking the most important questions while we still have the chance to seek answers. Fortunately, not all observational resources are subject to the same institutional constraints. Independent observatories around the world continue collecting data, and the scientific community remains fundamentally committed to truth-seeking despite occasional hesitancy. The European Space Agency's JUICE spacecraft will intercept 3 I-Atlas in November, providing another valuable observational platform, though the data transmission delays mean we won't see the results immediately. These observations could help resolve some of the current anomalies. Whether natural or otherwise, 3I Atlas represents a messenger from beyond our solar system, a tangible connection to the wider cosmos. The materials comprising its structure formed around another star, perhaps before our sun existed. Its path through space has been shaped by gravitational interactions we can only partially reconstruct. Its chemical composition tells stories of formation processes potentially different from those in our own planetary neighborhood.
In a few months, this visitor will have completed its brief tour of our solar system and begun its long journey onward.
Perhaps toward another star, another planetary system, carrying with it a few atoms and particles it collected during its passage near our sun, a cosmic exchange of matter across interstellar distances. There's something profoundly poetic in that reality, regardless of whether the object has any purpose beyond the gravitational dance dictated by physics. What I find most humbling is how a relatively small object, perhaps only a few kilometers across, can prompt such profound questions about our place in the universe. We've built telescopes that can see to the edge of the observable cosmos, yet we're still challenged by an interstellar visitor in our own celestial backyard. This juxtaposition of the vast and the intimate characterizes so much of astronomy. The most profound questions sometimes arrive in the most modest packages. As scientists, we'll continue analyzing the data, publishing papers, debating interpretations. That's our responsibility to knowledge. But as human beings, we might also take a moment to appreciate the wonder of this encounter. An object that formed around another star is passing through our neighborhood, briefly illuminated by our sun, observed by our instruments, contemplated by our minds. Across the immense gulfs of space and time, matter from different star systems has connected. There's a profound meaning in that connection, whether or not there's intent behind it. The coming weeks will bring new observations, new data, perhaps new anomalies or resolutions to existing ones. I'll be watching closely, as will many of my colleagues around the world. The story of 3I Atlas is still being written, its significance still being determined, but whatever conclusions we ultimately reach, this interstellar visitor has already achieved something remarkable. It has reminded us that the universe remains full of mysteries, full of possibilities beyond our current understanding. If you are as fascinated by these cosmic puzzles as I am, subscribe to join our ongoing conversation about the universe and our place within it. Every new discovery brings us closer to understanding the true nature of reality, and I believe this particular visitor might have more to teach us than we initially realized. Let's continue this journey of discovery together